Hello, friends. We're here to start our next chapter. You'd think we just finished up chapter 2 with equation solving, so, logically we should have chapter 3, but the curveball has been thrown. We have chapter 2.5. Yes, chapter 2.5 coming at you. Um, Fastball right down the middle. Hopefully, you can knock it out of the park here. What we did is we took kind of a larger chapter um, in our book, chapter 2, broke it down into two smaller chapters. So we've got the first half that we finished up with just equation solving. Second half here is going to take that equation solving and apply it to ratios, proportions, percents, and probability. So we'll take a look here to begin at what a ratio is. Now, a ratio is just simply comparing two numbers using the operation of division. So I've written out here, you may have, most of the time we're going to see it as A over B using that fraction bar notation. Word problems, you may see it written out as A to B. The colon here, dot, dot, A, dot, dot, B is the same meaning as A to B. And of course, you may see it as the old division symbol, A divided by B there. So those are all different ways you can denote a ratio. Next, we're going to look at a proportion, and proportions are just two ratios. So you got two ratios that are equivalent to each other. And how do you check whether or not two ratios are equivalent, that they form a proportion? Well, you check with taking their diagonal cross products. So here, 1/2 and 5/10, I'm saying those two ratios, 1 to 2 and 5 to 10, are equivalent. So they would be proportionate. I can show that by multiplying 2 times 5 is 10, and 10 times 1 is 10. So multiplying diagonally, you should get the same result, equal cross products. So let's show it here with -3/4 and -15/20, my diagonal cross products. 4 times -15 is -60, and then 20 times -3 is also -60. Since I have that -60 is -60, I know those two ratios do form a proportion. I'm going to look at the first three examples here. Again, we are showing our work, showing all the individual steps to earn full credit, because remember, the journey is just as, if not more important than, the destination. So I have proportions here. I have three examples, and we'll come back and finish up 4, 5, and 2 word problems. So since I'm told these are proportions, I can assume or concur that the diagonal cross products are equal. So what I'm trying to do is find what value over 5 is equivalent to 6/10. If anybody in the past has said, 5 times 2 is 10, so 3 times 2 is 6, don't do that. You were informed incorrectly. You always want to use diagonal cross products. Why? Well, when you take a look at more challenging examples, when you have multiple values in your fraction areas, your numerator or denominator, like in example 3, I have an x plus 2, that gets a little more tricky to do using mental math. All right, so make sure you use and show diagonal cross products. It is a little more work or a little more time consuming on these easier examples, but believe me, it will prevent you from making careless errors. So I'm going to multiply 5 times 6 and get 30, and have that equivalent to 10 times g, 10g. So to get g alone, I'm going to undo multiplying by 10. I'll divide both sides by 10, and g will equal 3. And if you're not sure about your answer, you can always delayed air freshener, plug it in, 3 for g. 3 times 10 is 30, 5 times 6, 30. So g equals 3 is our correct value to solve the proportion. Let's talk about a floater here, a minus sign out in front of a fraction. So I've got 2/3. And how do I make a minus sign get assigned to a fractional value? Do I put it to the top, the bottom, both, either? Well, if you put it to both terms, negative over negative, that would make the value a positive fraction. I don't want that. So if you have a minus sign floating out front, you can put it to either the top or the bottom. I'm just going to bring it to the top. That way I won't forget to multiply it out. 3 times 10, hey, there's that 30 number, will equal t times negative 2, negative 2t. Divide both sides by negative 2 to get t isolated, and I'll have t equals negative 15. So when we get to the third example here, here's where we have the multiple terms, this x plus 2 in the numerator of my first ratio. The process doesn't change. I'm still going to find the value of x by taking my diagonal cross products. But here's where I have to be really careful. Whenever I have multiple values, like an x plus 2, I want to put those in parentheses. Think about locking them up. That way, when I multiply, I'll take the 6 times 25 and get 150. I need to remind myself to multiply 30 times this whole top value to the x and the 2. That way, if I put it in parentheses, I'll remember to distribute multiplying the 30 to the x, 30x, the 30 to the 2, 60, that'll equal 1. So now I have a multi-step equation to solve for x. Subtract 60 from both sides. I'll have 30x equals 90. Divide both sides by 30. And believe it or not, x equals 3. Go ahead and check it if you want. 3 plus 2 is 5. 5 times 30, 150. 6 times 25, 150. So we're good there. We'll be back with the final 4 examples. All right, let's wrap up section 1 here for chapter 2.5. The last 2 kind of Nike examples where we're just going to do it. Again, I have multiple values in example 4, so I'm going to lock them up with parentheses. So I'm going to multiply 4 to x minus 2. So 4 times x minus 2 in parentheses will equal 8 times x plus 2. So I'll distribute and have 4x minus 8 will equal 8x plus 16. I'm now going to solve for x. I'll get the variable terms together on one side. Subtract 4x. Negative 8 will equal 8 minus 4, 4x plus 16. Subtract 16 from both sides. Negative 8 minus 16, negative 24 will equal 4x. Dividing by 4, x will be negative 6. So if I plug in negative 6 for x, negative 6 plus 2 is negative 4. Negative 6 minus 2, negative 8. Diagonal cross products, 8 times negative 4, negative 32 will equal negative 8 times 4, negative 32. So I'm good. I proved that x equals negative 6 is the solution for this proportion. All right, the big boy here, example 5, I have double floaters and multiple terms in the numerator of both ratios. So I'm going to take this minus sign and assign it to either the top or the bottom. In this case, I'm going to assign it to the bottom value because it's only one term. If it were the top, I'd have to assign it to the x and the 8, so negative x minus 8. It's easier, less work to bring it to one term. So I'll put parentheses around the x plus 8 and x minus 3, and then take my diagonal cross products. So I'll have negative 10 times x minus 3 in parentheses will equal negative 2 times x plus 8. I'll do a double distributive property. Negative 10x plus 30 will equal negative 2x minus 16. I'll now get the x values together, add 10x to both sides. Be left with 30 equals 10 minus 2, 8x. minus 16, add 16. 30 and 16 is going to be 46. That will equal 8x. Now you might be getting a little nervous. You might be thinking, whoa, 8 doesn't divide 46. It doesn't. Sometimes you may have a fraction or a decimal answer. That's okay. So when I divide by 8, 46 divided by 8. Well, 8 goes into 46 5 times with 6 left over. So 5 and 6/8 or 5 and 3/4. Or if you're a decimal person, 5.75. Any one of those is groove A. Maybe it's even groove I, or groove O, or groove U, but really it's groove E. Okay, enough of the grooving. Let's talk ratio proportion word problems. I am going to set up my proportion word problems with the scaffolding, the outline of fraction bar equals fraction bar. Okay, that's my kind of, how do you want to put it? The framework I want to have to get these proportions set up correctly. I'm going to read through the examples, and then I'm going to fill in the 4 positions, kind of starting in the bottom right and going counterclockwise. So if we read through example 6, it says the ratio of violets to roses in the garden was 13:7. If there were 63 roses in the garden, how many violets were present? Well, don't forget, roses are red, violets are blue, Frankenstein is ugly, and so are me. Not you, me. So I'm going to start bottom right with the total numerical value I'm given. I'm given a total of 63. And what that 63 is the number of roses. So I'm just going to put a little r here to say, okay, that's my number of roses. I'm going to start then, after I write down the total, with putting in the variable. What am I trying to find? I'm trying to find how many violets were present. So then I am going to match with my violets the number I'm given in the specific proportion. So I'm told the ratio of violets to roses was 13:7. So violets, does that number match up with the 13 or the 7? I got to read through and say, okay, which came first? Violets comes first, 2 roses, then it's 13:7. So violets will match up with the number 13. 63, the number of roses, matches up with the 7. So I'm going to take diagonal cross products here and solve away for V, the number of violets. So 7 times V, I'll have 7V. That'll equal 63 times 13. Crunch it out. See if you can beat me. Did you get 819? I did. Divide both sides by 7. I'm going to get violets is a grand total of 117. Isn't that beautiful? Oh, lovely. All right. Last one here is a little bit different, but we got to be careful with the setup. We're told the ratio of boys to girls at the social gathering was 8:5. So for every 8 boys, there were 5 girls. If there were a total of 117 people who attended, how many were girls? So 117 is my total number of people who attended. Is that boys or girls? Well, it's neither. It's actually both. So I'm just going to put a little B plus G. That's my boys plus girls. Total of both. My variable, I want to find how many were girls. So I'm going to put a G in my upper right position. I'm going to match that up now with the given ratio of 8:5. So it says boys, 2 girls. So girls came second in the description. So the second number is a 5. Now this 117, the total is the total of both. So how do I find the total of both 8 and 5? Well, you guessed it, add them together. 8 plus 5 will give 13. So I'll take my diagonal cross products. I'll have 13 times g, 13g will equal 5 times 117. So that'll be, I believe, 585. So 13g will equal 585. Divide by 13. And I'll get g, the number of girls, is 45. There you have it. I hope you have a great day. Fly on. Thanks for your efforts.